All right, let's look at a problem with 3D vectors and coordinate direction angles and see how we approach these problems. The problem says determine the x, y, and z components of the 500 Newton force, and also the angles theta x, theta y, and theta z. This one is given already. This one is theta y, the angle that the force makes with y-axis, but we don't know the angle that it makes with z-axis, and we don't know the angle that it makes with x-axis. So first find the components, fx, fy, and fz of this 500 Newton force, and the other one. So these two are very similar, the 800 and 500. I'll do the 500, you do the 800 as practice. All right, let's get it started. So I'm going to redraw it quick here, kind of make sure we understand what we are dealing with. So I have $500, and it's kind of casting a shadow. I like to call this a shadow right here. Call this a shadow. So if you have some light coming from top, this is a shadow of this vector on xz plane. So let's find this shadow first. We'll call it S. So I'm going to look at this S. It looks like this: 500 newtons. This is the shadow. So the light comes from top. It's making a shadow. This is the S. I'm just looking at the perpendicular. This angle here, if this angle is 40, that means this angle here is 50. So this is 50. So let's see. If I write cosine of 50 for this triangle that I just drew here, it would be this shadow S over hypotenuse, which is 500 newtons. So therefore S, the magnitude of S, would be 500 cosine 50, which I did the math for you, 321.4 newtons. So this shadow here is 321.4. All right. Now I got to look at xz plane, so I'm going to redraw it here a little bit. I'm looking at it again perpendicular. This is the S that I just found, which I said is 321.4 newtons. It makes an angle of 30 degrees here. As a result, 60 degrees here. All right. If I go parallel to z-axis, I have fx. If I go parallel to x, I have fz, and I can write these two right here. So fx, it's an adjacent, so it's going to be 321.4 cosine 30, and that will result in 278.3 newtons. So if I want to just write as a final answer, if you want to consider three significant figures, that's your fx. Your fz is going to be 321.4 cosine 60 or sine 30. Either way will work. Cosine 60, and that will result in 160.7. Again, three significant figures. I'm just going to write it as 161. Okay, what are we missing? Fy. Okay, Fy is given. The angle is given. If I'm only looking at y and the shadow plane straight, this if I'm looking right here, okay, I'm going to draw it right here. This is the 500. This is 40. And this is my Fy that I'm interested in. So all I have to do is Fy equal 500 cosine 40. And that will result in 383.02. So Fy, 3 significant figures, 383 newtons. So that's part A. Part A is done. Part B, it says find the angle theta x, theta y, and theta z. These are the angles that the 500 makes with each axis. So let's clean this up and let's start working on that one. So remember, a vector, if all three angles are known, z, x, this is a 3D vector, vector f. It makes angle alpha with x-axis, beta with y-axis, and gamma with z-axis. You can write a vector as magnitude of f cosine theta, or I'm using alpha beta, so let's just use that. Cosine alpha I, cosine beta j, cosine gamma k. Sorry. If you want the theory or learn why is this, you got to go back and watch the video when I cover this, and I go over why we can express a vector in a vector using coordinate direction angles. Okay, the alpha, beta, and gamma. In this case, it just says theta x, theta y, theta z. Same thing. Theta x, theta y, theta z. All right. From previous slide, I have fx is, how much was it? 278. These are magnitudes. Fy is 383. And Fz was 161. Okay. F cosine theta xi, this is fx without the I, sorry. F cosine beta j, this is fy. F cosine gamma k, this is fz. So 278 newtons equals 500 cosine theta x. Okay, so as a result, your theta x is going to be 56.2 degrees. We'll do the same for Fy. Do we have to do it? We don't. It's given. It's already 40. Well, let's do the math. Make sure everything checks out. 383 newtons equals 500 cosine beta. If you do the math, your beta, or sorry, theta y, different notation, should equal to 40. Well, that checks out. And then lastly, Fz 161, or you can use 160.7 to be accurate, but that's all right. Newtons equal 500 cosine gamma. And as a result, your gamma or theta z or gamma is going to be 71.3. Okay, so follow my steps, pause the video as many times as you want, and you do the 800, do the same thing for 800 yourself. First, find the components of 800 on y, on x and z, and then find the angles that 800 makes with each of the axes. Here's a little hint. The 70 is given, so your theta y, you can find it easy without calculation. But here's how you approach problems such as this one. Thank you.